Hello, in this lecture we will find the radius of a circle. In the drawing we have the blue circle, and the blue circle blocks quadrilateral ABCD, or quadrilateral ABCD is inscribed by the blue circle, and we also know that side AB of quadrilateral ABCD equals to 3 units, so we will define side AB as A, therefore A will be equal to 3 units, and we also know that side BC of quadrilateral ABCD equals to 4 units, so we will define side BC as B, and therefore B will be equal to 4 units. Side CD of quadrilateral ABCD equals to 5 units, so we will define side CD as C, that is to say CD equals to C, and C will be equal to 5 units, and side AD of quadrilateral ABCD equals to 6 units, so we will define side AD as D, that is to say AD equals to D, and D will be equal to 6 units. And we want to find out the radius of this blue circle that blocks quadrilateral ABCD. So, in order to find out the radius of this blue circle, I will present to you 3 new rules, and we will implement the 3 new rules in our drawing. So, rule number 1 is that the area of quadrilateral ABCD inscribed by a circle equals to actually this is the sign of area, this means the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D. Actually, A, B, C, and D are the lengths of quadrilateral ABCD. In our specific case, A equals to 3, B equals to 4, and C equals to 5, and D equals to 6, but it could be any other quadrilateral, and A, B, C, and D are the lengths of the quadrilateral sides, and S equals to A plus B plus C plus D over 2. Okay? So, actually, if you have this circle, and inside this circle blocks quadrilateral ABCD. So this is quadrilateral ABCD that is inscribed by this blue circle, and we also know that side AB of quadrilateral ABCD equals to A units in its size, side BC of quadrilateral ABCD equals to B units in its size, side CD equals to C units in its size, and side AD of quadrilateral ABCD equals to D units in its size. Then, according to rule number 1, only if you have a quadrilateral that it is inscribed by a circle, like in this drawing, only then you can calculate the area of this quadrilateral according to the formula that the area of this quadrilateral ABCD, that could be any quadrilateral, again this is the sign of area, so it means the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of quadrilateral ABCD. Again, A, the size of side AB of quadrilateral ABCD here equals to A units, the size of BC is B units, the size of side CD is C units, and the size of side AD of quadrilateral ABCD is D units, equals to D units, and therefore the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, and S equals to A plus B plus C plus D over 2. That is the sum of quadrilateral ABCD sides over 2. Okay, so this is rule number 1, and we also have rule number 2. Rule number 2 states that if quadrilateral ABCD inscribed by a circle if quadrilateral ABCD is inscribed by a circle then the product of its diagonals equals to the sum of products of its opposite sides. So I read rule number 2 again. Rule number 2 states that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of products of its opposite sides. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle and inside this circle there is quadrilateral ABCD, or quadrilateral ABCD is inscribed by this blue circle, so actually this is quadrilateral ABCD that is inscribed by this blue circle. Quadrilateral ABCD has two diagonals. The first diagonal BD, we will define diagonal BD as x, that is to say the size of diagonal BD equals to x units, and we also, it has quadrilateral ABCD as second diagonal, that is diagonal AC. So we will define diagonal AC as y, that is to say the size of AC is y units. So if you have quadrilateral ABCD that is inscribed by a circle, and only we are talking only on quadrilaterals that are inscribed by a circle, like in this drawing, then if we have quadrilateral that is inscribed by a circle, then according to rule number 2, the product of its diagonals of quadrilateral ABCD, the product of its diagonals, it is actually x times y, equals to the sum of the product of its opposite sides. Actually, quadrilateral ABCD has two pairs of opposite sides. The first pair of opposite sides is side BC is opposite to side AD, and the second pair of opposite sides, it is actually side AB is opposite to side DC. First of all, we will define side AB as A, that is to say side AB equals to A units in its size. Side BC will be defined as B, that is to say side BC equals to B units in its size. And we will also define side CD as C, that is to say side CD equals to C units in its size, and we will define side AD as D, that is to say the size of side AD is D units. So actually, according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the product of its opposite sides. As I already said, quadrilateral ABCD has two pairs of opposite sides. The first pair of opposite sides is BC, is opposite to side AD, and the product of the first opposite sides, it is actually B times D, and it also has the second opposite side. Side AB is opposite to side DC, and the product of the opposite sides and of the second pair is actually A times C. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. So we have two products of the opposite sides, product BD and product AC, and the sum of the products of its opposite sides, it is actually BD plus AC. So according to rule number 2, XY, that is the product of its diagonals, equals to the sum of the products of its opposite sides, that is to say to BD plus AC. Okay, so I repeat again. If quadrilateral ABCD is inscribed by a circle, like in this drawing, and we are talking only on quadrilaterals that are inscribed by a circle, then the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. And the sum of the product of its opposite sides, it is actually BD plus AC. The first product is BD, the second product is AC, and the sum of the product of its opposite sides, it is actually BD plus AC, and that sum of the products of its opposite sides equals to the product of its diagonals, that is to say XY. So XY equals to BD plus AC. Okay, that is rule number 2. And we also have rule number 3. According to rule number 3, rule number 3 states that if a triangle is inscribed by a circle, if triangle ABC, that could be any triangle, and we are talking only on triangles that are inscribed by a circle. Rule number 3 applies only on triangles that are inscribed by a circle. So if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. I will repeat on rule number 3 again. Rule number 3 states that if triangle ABC is inscribed by a circle, then the radius of that circle that blocks triangle ABC equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So what is the meaning of rule number 3? The meaning of rule number 3 is that if you have this circle and we have this circle blocks triangle ABC, or triangle ABC is inscribed by this circle, so this is triangle ABC. Triangle ABC is inscribed by this blue circle, and we also know that side AB of triangle ABC equals to A units in its size, side BC of triangle ABC equals to B units in its size, and side AC of triangle ABC equals to C units in its size. So according to rule number 3, if triangle ABC is inscribed by a circle, like in this drawing, the red triangle ABC is inscribed by the blue circle, then the radius of that circle, the radius of this blue circle that blocks triangle ABC equals to the product of the triangle sides. So the radius of this blue circle, that is to say capital R, that blocks triangle ABC equals to the product of triangle ABC sides. The product of triangle ABC sides, it is actually A times B times C over 4 times the area of triangle ABC, over 4 times the area of triangle ABC. Okay, so I will repeat again. Rule number 3 apply only to triangles that are inscribed by a circle, like in this drawing. So if you have triangle that is inscribed by a circle, then the radius of that circle that blocks the triangle, in this case the radius of this blue circle that blocks triangle ABC, will be equal to the product of triangle ABC sides. The product of triangle ABC sides is A times B times C over 4 times the area of triangle ABC. Okay, that is rule number 3. And we will actually implement all 3 new rules in our specific drawing. So if we focus on our drawing, according to rule number 1, the area of this quadrilateral ABCD will be equal, I'll repeat again, rule number 1 applies only of quadrilateral that are inscribed by a circle, like in this drawing. So the area of a triangle that is inscribed by a circle equals to the root of S minus A times S minus B times S minus C times S minus D. Okay, according to rule number 1, the area of this red quadrilateral that is inscribed by a circle equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of this quadrilateral ABC sides. A equals to 3, B equals to 4, C equals to 5, and D equals to 6. And S equals to A plus B plus C plus D over 2. So this is the implementation of rule number 1 in our drawing. And we'll implement rule number 2 in our drawing. So we have this red quadrilateral that is inscribed by this blue circle, and also quadrilateral ABCD has two diagonals. The first diagonal is diagonal AC. So we will define diagonal AC as x, that is to say the size of diagonal AC equals to x units, and we will define diagonal BD of quadrilateral ABCD as y, that is to say the size of diagonal BD equals to y units. So according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. The first product of its opposite sides is BD, and the second product of its opposite sides is AC. And the sum of the product of its opposite sides, it is actually BD plus AC, and that sum of the product of its opposite sides, that is BD plus AC, equals to the product of its diagonals, that is to say XY, equals to BD plus AC according to rule number 2. And we will implement also rule number 3 in our drawing. So if we relate to triangle ABC, so this triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABC, that is to say capital R, will be equal to the product of triangle ABC sides, and the product of triangle ABC sides, it is actually A times B times X over 4 times the area of triangle ABC. This is according to rule number 3. I will repeat again. Actually, this triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABC, capital R, will be equal to the product of triangle ABC sides, and the product of triangle ABC sides, it is actually A times B times X over 4 times the area of triangle ABC. Okay, so here we will multiply equation number 3 by the area of triangle ABC, and we will get that R times the area of triangle ABC equals to ABX over 4. So here we will divide equation number 3 by R, and we will get that the area of triangle ABC according to equation number 3 equals to ABX over 4R. Okay, so we found out the area of triangle ABC. So in the next step we will focus on triangle ADC. Okay, so in triangle ADC, so here, as you can see from the drawing, this triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ADC equals to the product of triangle ADC sides, that is to say, it equals to C times D times X over 4 times the area of triangle ADC. This is according to rule number 3. Again, triangle ADC is blocked by this blue circle, or triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ADC will be equal to the product of triangle ADC sides, that is to say, it will be equal to C times D times X over 4 times the area of triangle ADC. So here we will, according to rule number 3 of course, we will multiply equation number 4 by the area of triangle ADC, and we will get that R times the area of triangle ADC equals to CDX over 4. Here we will divide equation number 4 by R, and we will get that the area of triangle ADC according to equation number 4 equals to CDX over 4R. Okay? But we have already found out that the area of triangle ABC according to equation number 3 equals to ABX over 4R. Okay? But if you look at the drawing, you can see that if we combine the area of triangle ABC with the area of triangle ADC, we combine those two triangles together, we will get the quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC, this triangle, plus the area of triangle ADC, this triangle. I'll repeat again. Quadrilateral ABCD consists of two triangles, triangle ABC and triangle ADC. Therefore, the area of triangle ABCD, the area of quadrilateral ABCD, will be equal to the area of triangle ABC plus the area of triangle ADC. So the area of quadrilateral ABCD according to equation number 1 will be equal to the area of triangle ABC. We've already found out that the area of triangle ABC equals to ABX over 4R plus the area of triangle ADC. And we have already found out that the area of triangle ADC equals to CDX over 4R. So here we take x over 4R as a common factor out of these two expressions, and we will get that the area of triangle ABCD, the area of quadrilateral ABCD, equals to x over 4R is a common factor of those two expressions. So inside the brackets, what is left after we took x over 4R as a common factor, what is left is actually AB, and what is left in this from this expression after we took x over 4R as a common factor, what is left is it is actually CD. So we found out that the area of quadrilateral ABCD according to equation number 1 equals to x over 4R times AB plus CD. Okay, so in the next step we will focus on triangle BDC. So in triangle BDC, or actually triangle BDC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle BDC, that is to say capital R, will be equal to the product of triangle BDC sides, that is to say it will be equal to B times C times Y over 4 times the area of triangle BDC. I repeat again, triangle BDC is inscribed by this blue circle, therefore, according to rule number 3, the radius of the blue circle that blocks triangle BDC equals to the product of triangle BDC sides, that is to say, it equals to B times C times Y, B times C times Y over 4 times the area of triangle BDC. So here we'll multiply equation number 5 by the area of triangle BDC, and we will get that R times the area of triangle BDC equals to BCY over 4. Here we will divide the equation number 5 by R, and we will get the area of triangle BDC. We actually get that the area of triangle BDC according to equation number 5 equals to BCY over 4R. So we actually found out the area of triangle BDC according to equation number 5. The area of triangle BDC equals to BCY over 4R. So in the next step we will focus on triangle ABD. And triangle ABD, actually triangle ABD, this triangle is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ABD, that is to say capital R, will be equal to the product of triangle ABD sides, that is to say it will be equal to A times D times Y over 4 times the area of triangle ABD. This is according to rule number 3. I will repeat again. Triangle ABD is inscribed by this blue circle, therefore according to rule number 3, the area of the blue circle that blocks triangle ABD will be equal to the product of triangle ABD sides, that is to say it will be equal to A times D times Y over 4 times the area of triangle ABD. Here we will multiply equation number 6 by the area of triangle ABD, and we will get that R times the area of triangle ABD equals to ADY over 4 so we multiply this equation number 6 by the area of triangle ABD, and we get that R times the area of triangle ABD equals to ADY over 4. Here we will divide the equation number 6 by R, and we will get the area of triangle ABD. We will get that the area of triangle ABD according to equation number 6 will be equal to ADY over 4R. Okay? And we have already found out that the area of triangle BDC according to equation number 5 equals to BCY over 4R. Okay? So, but as you can see from the drawing, if we combine triangle BDC with triangle ABD, if we combine those two triangles together, we will get exactly the quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD. So I will write it down. The area of quadrilateral ABCD according to equation number 2 will be equal to the area of triangle BDC plus the area of triangle ABD. I repeat again, the area of quadrilateral ABCD equals to the area of triangle BDC plus the area of triangle ABD, because of the fact that quadrilateral ABCD consists of those two triangles, triangle BDC plus triangle ABD. Okay, so the area of quadrilateral ABCD according to equation number 2 equals to the area of triangle BDC. We've already found out that the area of triangle BDC equals to BCY over 4R plus the area of triangle ABD. We've already found out that the area of triangle ABD equals to ADY over 4R. So here we'll take a common factor of y over 4r out of this expressions, and we will get that the area of quadrilateral ABCD according to equation number 2 equals to y over 4r is a common factor. So inside the brackets we will have here what is left after we took y over 4r as a common factor. What is left is actually BC, and what is left here is AD. So in total we got that the area of quadrilateral ABCD according to equation number 2 equals to y over 4r times BC plus AD. Okay? But we have already found out, according to equation number 1, that the area of quadrilateral ABCD equals to x over 4r times AB plus CD. Okay, so we have two different expressions for the area of quadrilateral ABCD. So here we will multiply equation number 1 by equation number 2, and we will get equation number 3, that is actually the area of quadrilateral ABCD squared equals to x times y over 4r squared times BC plus AD times AB plus CD. So here we take a root out of equation number 3, and we will get that the area of quadrilateral ABCD according to equation number 3 equals to the root of the numerator, that is to say xy BC plus AD times AB plus CD. And the root of 4r squared is 4r, because of the fact that the root cancels the square, and what is left is only 4r. So we actually found out that the area of quadrilateral ABCD according to equation number 3 equals to the root of this expression over 4r. Here we will multiply equation number 3 by r, and then we divide it by the area of quadrilateral ABCD. So first of all we will multiply equation number 3 by r, and we will get that r times the area of quadrilateral ABCD equals to the root of xy BC plus AD AB plus CD over 4. So here we will divide the equation number 3 by the area of quadrilateral ABCD, and we will get the radius that we are looking for, that is to say capital R, will be equal to the root of xy times BC plus AD times AB plus CD over 4 times the area of quadrilateral ABCD. So we have x times y inside the root on this side of the equation number 3. But we know that according to rule number 2, xy equals to AC plus BD. According to rule number 2. Therefore, we can substitute xy in equation number 3 by AC plus BD. Okay, so we do it now, and we will get that the radius that we are looking for equals to the root of, so instead of xy we will write down AC plus BD, that equals to xy, AC plus BD times BC plus AD times AB plus CD over 4 times the area of quadrilateral ABCD. So the only thing that is left to find out is to find out the area of quadrilateral ABCD. We've already found out the area of quadrilateral ABCD. I will repeat on the same process again. According to rule number 1, the area of quadrilateral ABCD that is inscribed by this blue circle equals to the root of S minus A times S minus B times S minus C times S minus D, when A equals to 3, B equals to 4, C equals to 5, and D equals to 6, and S equals to A plus B plus C plus D over 2. That is according to rule number 1. We have already talked about it. Okay, so first of all we will find out the value of S, and then we will put the value of S inside this equality. So here we know that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So S will be equal to A is 3, plus B is 4, plus C is 5, and D is 6 over 2. So here 3 plus 4 is 7, and 7 plus 5 is 12, and 12 plus 6 is 18. 18 over 2 is 9, so we found out that S equals to 9. So we'll substitute S in this equality by 9, and we will get that the area of quadrilateral ABCD equals to the root of S minus A. S is 9, A is 3, this is 9 minus 3, S minus A is 9 minus 3. S minus B, S is 9, B is 4, so it is 9 minus 4. S minus C, S is 9, C is 5, so it is 9 minus 5. And S minus D, S is 9, and D is 6, so it is 9 minus 6. So actually the area of quadrilateral ABCD according to this equality equals to the root of 9 minus 3 is 6, 9 minus 4 is 5, 9 minus 5 is 4, and 9 minus 6 is 3. So we found out that the area of quadrilateral ABCD equals to the root of 6 times 5 times 4 times 3. So here the area of quadrilateral ABCD equals to the root of 6 times 5 is 30, 30 times 4 is 120, and 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360 square units. So after we found out the area of quadrilateral ABCD, we can substitute the area of quadrilateral ABCD in equation number 3 by the root of 360 square units that we found out. So we'll do it now, and we will get that the radius that we are looking for according to equation number 3 equals to the root of AC plus BD times BC plus AD plus AB plus CD. All divided by the area of quadrilateral ABCD, that is actually root of 360, and all divided by 4. So actually the radius that we are looking for will be equal according to equation number 3, R equals to the root of, I will write down the values of A, B, C, and D. A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So R equals to AC, A is 3, C is 5, so A times C is 15, plus BD. B is 4, D is 6, 4 times 6 is 24, times BC. B is 4, C is 5, 5 times 4 is 20, plus AD. A is 3, D is 6, 3 times 6 is 18, AB. A is 3, B is 4, so 3 times 4 is 12, plus CD. C is 5, D is 6, so 5 times 6 is 30, all divided by 360, and divided by 4. So we actually found out that the radius that we are looking for equals to this expression. So we do the simple arithmetic here, and we will get that R equals to the root of 15 plus 24 is 39, 20 plus 18 is 38, and 12 plus 30 is 42, all divided by 360 over 4. So the radius that we are looking for equals to this expression here. 39 times 38 times 42 over 360 is 172.9. So write it down. So R equals to the root of 172.9 over 4 units, or in terms of numbers, R equals to 3.287 units. I'll repeat again. The radius of this circle equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, that is the answer to the question. So now I will summarize the lecture. Actually, we wanted to find out the area, the radius of this circle that blocks the quadrilateral ABCD, or quadrilateral ABCD is described by this blue circle, and we know that AB equals to 3 units, so we defined AB as A, and A equals to 3. BC equals to 4 units, so we defined BC as 4. We defined BC as B, and B equals to 4. And CD equals to 5 units, so we define CD as C, and C equals to 5. And AD equals to 6 units, so we defined AD as D, so D will be equal to 6 units. And we want to find out the radius of this circle that blocks quadrilateral ABCD. Okay, so in order to find out the radius of this blue circle, I presented to you 3 new rules, and we implemented the rules in our drawing. Actually, rule number 1 is that the area of quadrilateral ABCD inscribed by a circle equals to, this is the sign of the area, okay, 2 brackets. So the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of the quadrilateral sides. AB equals to A units in its size, BC equals to B units in its size, CD equals to C units in its size, and AD equals to D units in its size, and S equals to A plus B plus C plus D over 2. So whenever you have quadrilateral that is inscribed by a circle, then you can find out the area of this quadrilateral according to this equation. So that is actually rule number 1. And we also have rule number 2. According to rule number 2, if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of products of its opposite sides. So if we have this quadrilateral ABC that is inscribed by this blue circle, so we are talking only of quadrilaterals that are inscribed by a circle, like in this drawing, then the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides. And the sum of the products of its opposite sides, it is actually BD plus AC. Okay, so the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides, equals to BD plus AC. This is actually the sum of the products of its opposite sides. Okay, that is rule number 2. And we also have rule number 3. According to rule number 3, if triangle ABC is inscribed by a circle, then the radius of that circle equals to the product of triangle ABC sides over 4 times the area of triangle ABC. So if we have triangle ABC that is inscribed by a circle, we are talking only on triangles that are inscribed by a circle, like in this drawing. Okay, so if we have triangle that is inscribed by a circle, then the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say will be equal to A times B times C over 4 times the area of triangle ABC. So whenever we have triangle that is inscribed by a circle, we can calculate the radius of the circle that is blocks the triangle according to this formula. The radius will be equal to the product of the triangle's sides, the triangle that is inscribed by the circle, over 4 times the area of the triangle. Okay, that is rule number 3. We actually implemented the 3 new rules in our specific drawing. According to rule number 1, the area of this quadrilateral that is inscribed by this blue circle equals to the root of s minus a times s minus b times s minus c times s minus d, when a, b, c, and d are the lengths of quadrilateral ABC sides, that is to say a equals to 3, b equals to 4, c equals to 5, and d equals to 6, and s equals to a plus b plus c plus d over 2. This is according to rule number 1. And we also implemented rule number 2 in our drawing. According to rule number 2, if we have quadrilateral ABC that is inscribed by a circle, and only on quadrilaterals that are inscribed by a circle, rule number 2 is applied. So if we have quadrilateral ABC that is inscribed by a circle, then the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides, equals to BD plus AC. Okay, x times y equals to BD plus AC. And we also have rule number 3. Rule number 3 states that if triangle ABC is inscribed by a circle, then the radius of this circle will be equal to the product of triangle ABC sides, this triangle, over 4 times the area of the triangle ABC. So it doesn't matter at all in which triangle we are talking. Any triangle that is inscribed by a circle, we can use rule number 3. We can calculate the radius of that circle that blocks the triangle. The radius will be equal to the product of the triangle's sides over 4 times the area of the triangle. Okay, in this case, it is actually a times b times x over 4 times the area of triangle ABC. Okay, so here we multiply the equation number 3 by the area of triangle ABC, and we got that r times the area of triangle ABC equals to abx over 4. Here we divided equation number 3 by r, and we got that the area of quadrilateral ABC according to equation number 3 equals to abx over 4r. Then we focus on this triangle, triangle ADC. triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ADC will be equal to the product of triangle ADC sides. That is to say, it will be equal to C times D times X over 4 times the area of triangle ADC. Here we, according to rule number 3, of course, so here we multiplied equation number 4 by the area of triangle ADC, and we got that R times the area of triangle ADC equals to CDX over 4. Then we divided equation number 4 by R, and we got that the area of triangle ADC equals to CDX over 4R. But we have already found out, according to equation number 3, that the area of triangle ABC equals to ABX over 4R. So we have the areas of triangle ADC and triangle ABC. But what is, as you can see from the drawing, if you combine triangle ADC with triangle ABC, if we combine those triangles together, we will get quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC, because of the fact that quadrilateral ABCD consists of those two triangles. So according to equation number 1, the area of quadrilateral ABCD equals to the area of triangle ABC plus the area of triangle ADC. But we have already found out that the area of triangle ABC equals to ABX over 4R, and the area of triangle ADC equals to CDX over 4R. Okay, here we took a common factor of x over 4R out of this equality, and we got that the area of quadrilateral ABCD equals to x over 4R times AB plus CD. Then we focused on this triangle, triangle BDC. This triangle BDC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say, will be equal to B times C times Y over 4 times the area of triangle BDC, according to equation rule number 3. Here we multiplied equation number 5 by the area of triangle BDC, and we got that R times the area of triangle BDC equals to BCY over 4. Then we divided equation number 5, this equation by R, and we got that the area of quadrilateral BDC equals to BCY over 4R. Okay, then we focused on triangle ABD. We know that triangle ABD is inscribed by this blue circle. Therefore, the radius of this blue circle that blocks triangle ABD will be equal, according to rule number 3, will be equal to the product of triangle ABD sides. That is to say, will be equal to A times D times Y over 4 times the area of triangle ABD, according to rule number 3. Then we multiply the equation number 6 by the area of triangle ABD, and we got that R times the area of triangle ABD equals to ADY over 4. Then we divided the equation number 6 by R, and we got that the area of triangle ABD equals to ADY over 4R, and we have already found out, according to equation number 5, that the area of triangle BDC equals to BCY over 4R. Okay? But as you can see from the drawing, if we combine triangle BDC with triangle ADB, we will get quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD. Okay? So, the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD. But we have already found out that the area of triangle BDC equals to BCY over 4R, and the area of triangle ABD equals to ABY over 4R. Okay? So, the area of quadrilateral ABCD equals to BCY over 4R plus ABY over 4R. Here we took out the common factor of y over 4 out of these two expressions, and we got that the area of quadrilateral ABCD equals to y over 4r times BC plus AB. But we already found out that the area of quadrilateral ABCD, according to equation number 1, equals to x over 4r times AB plus CD. So we have two different expressions for the area of quadrilateral ABCD. So we multiplied the equation number 1 by equation number 2, and we got that the area of quadrilateral ABCD squared equals to this expression. Then we took out a root out of equation number 3, and we got that the area of triangle ABC equals to the root of the numerator, and the root of 4r squared is 4r. Okay, 4r, and here we multiply the equation number 3 by r, we got this expression. Then we divided the equation number 3 by the area of quadrilateral ABCD, and we got the radius that we are looking for. The radius equals to this expression. So the only thing that is missing is to find out the area of quadrilateral ABCD. But before that, we know that xy equals to AC plus BD according to rule number 2. So we can substitute xy in this equation number 3 by AC plus BD. So we substituted xy by AC plus BD, and we got this expression. And here the only thing that is left to find is to find out the area of quadrilateral ABCD. We've already found the area of quadrilateral ABCD, so I repeated on the same process. According to rule number 1, the area of quadrilateral ABCD equals to the root of s minus a times s minus b times s minus c times s minus d, when a, b, c, and d are the lengths of quadrilateral ABCD square. A equals to 3, b equals to 4, c equals to 5, and d equals to 6. And s equals to a plus b plus c plus d over 2 according to rule number 1. So we found out the value of s. S equals to a is 3, b is 4, c is 5, and d is 6. So 3 plus 4 plus 5 plus 6 over 2 is 18 over 2 is 9. So we found out that s equals to 9. So we can substitute s in this equality by 9. So here s minus a, s is 9, a is 3. S minus b, s is 9, b is 4. S minus c, s is 9, c is 5. S minus d, s is 9, d is 6. So it is 9 minus 6. So we got this expression for the area of quadrilateral ABCD. So here 9 minus 3 is 6, 9 minus 4 is 5, 9 minus 5 is 4, and the 9 minus 6 is 3. So in total we got that the area of quadrilateral ABCD equals to the root of 6 times 5 times 4 times 3. 6 times 5 is 30, 30 times 4 is 120, and 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360 square units. So therefore we can substitute the area of quadrilateral ABCD by the root of 360 in this equation number 3. So we substituted the area of quadrilateral ABCD by the root of 360, and we got this expression. So the only thing that is left to do is to put the data inside this equality. And what is AC? A is 3, C is 5. 3 times 5 is 15. What is BD? B is 4, D is 6. 4 times 6 is 24. What is BC? B is 4, C is 5. 4 times 5 is 20. What is AD? A is 3, D is 6. 3 times 6 is 18. Again, it is here we have, okay, 18. and we have also AB. A is 3, B is 4, so 3 times 4 is 12. And we have also CB. C is 5, it is actually CD. C is 5, D is 6, so 5 times 6 is 30. So in total we got this expression for the radius of the circle that we are looking for. So here 15 plus 24 is 39, 20 plus 13, 20 plus 18 is 38, and 12 plus 30 is 42. So we got this expression for the radius of the circle. 39 times 38 times 42 over 360, it is 172.9, all divided by 4. So we found out that the radius of this circle that blocks the quadrilateral ABCD equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this blue circle equals to 3.287 units. I will repeat again. The radius of this circle that blocks quadrilateral ABCD equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this blue circle equals to 3.287 units. Okay, thank you very much.